Hello. So, welcome to the second lecture for Mathematics Class 11, Chapter 7, Linear Inequalities. So, yesterday we saw or we started to understand what are linear inequalities. Okay, so the linear inequalities are those, they are a type of, expression, but instead of an equal to sign, we use other. So, so instead of equal to sign, equal sign, we use signs of inequality. Inequality to represent values or mathematical expressions. Okay, so these are linear inequalities. So, for example, if we write 3x is less than 9, okay, or you can get so the signs of inequality, as we have seen, is less than, greater than, less than or equal to, or greater than or equal to. Okay, so these are the signs that we use when we are trying to represent some statements in the form of linear inequalities. Okay, so it can be 5x plus y is less than 0. Okay, so in any form, in these forms, whatever you can express, these are called linear inequalities. Then we saw that you are using, if less than or greater than signs are used, the linear inequalities can be categorized as strict inequalities. Okay, so strict as in there is a very hard and fast limit. So the example that we've used, so the 3x, the value of 3x has to be less than 9. It cannot be equal to 9 at any case. But if we use less than or equal to or greater than or equal to signs are used, we have what are called slack inequalities. Okay, so these are some of the important takeaways that we have already addressed in the previous class. So this is like a quick revision. Also, we have, for example, when we are saying 5x plus y is equals to 0, this is an inequality with two variables. Okay, two variables are being used over here. And if you have 3x is equals to 9, then this is inequality or linear inequality with one variable. Okay, so for today, we will be mostly focusing on kind of understanding, in one variable, what can be with, what kind of algebraic operations can be done with using linear inequality, which consists of only one variable. Okay, so to get into that, we will try to understand, okay, up to what limit can you solve the linear inequalities. Okay, so when we have to find the value of x, it has to adhere to the condition that is being already mentioned. Okay, whether it's less than or greater than a certain value, or less than or equal to, or greater than or equal to some value. Okay, so we will take an example of 30x is less than 300. Okay, let's take this as an example. So for when x is equals to, say, 0, your LHS. Okay, so 30x is going to be LHS. So 30 into 0 is equals to 30. Oh, sorry, is equals to 0, which is less than 300. Similarly, if you take x is equals to 1, you have LHS that is 30 into 1, that is again 30, which is less than 300, and x is equals to 2, LHS. So 30 into 2, 60, less than 300. Okay. Then x is equals to 3. You have 30 into 3, 90, which is again less than 300. X is equals to 4. 30 into 4 is 120, less than 300. X is equals to 5. 30 into 5 is equals to 150, less than 300. X is equals to 6. 50 into 180, 300. So 730 into 7 to 10 is less than 300. Then we have x is equals to 8. So we have 30 into 8 to 40, less than 300. X is equals to 9. 30 into 9 to 70, less than 300. Okay, and if you take x is equals to 10, 30 into 10 is equals to 300. Okay, so we will see which of these, for which of the values of x is our statement, that is 30x is less than 300. Okay. Okay. So, we have got up till the value of 300 and also, one step beyond that. So you can see for all the values of x, so when x is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So for x is equals to 0, 1 to 0, from 0 up to 9, the statement is statement 30x less than 300 is true. Okay. But for x is equals to 10 and 11, statement is false. Okay, is false. Why? Because we are giving, okay, in the statement we have mentioned that 30x has to be less than 300. So when your x is equals to 10, it becomes equal to 300, which is, we have only mentioned that the value of x has to be such that 30x has to be less than 300. That's why 10 and 11 are false, whereas all the other values of x make the statement true. Okay, so therefore, so all the values of x, okay, all values of x for which the statement, so the statement that we're trying to solve, okay, so the statement is true, are called solutions. Okay, so all the values, okay, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all the solutions. Okay, solutions of the inequality. Okay, that is 30x less than 300. And therefore, the set, okay, so x is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this set is called the solution set. Okay, so we can see that any solution of this inequality, okay, is one variable. Okay, over here we are considering only one variable. Okay, so any solution of an inequality in one variable is a value of the variable, which makes it a true statement. Okay, so the value of x, which makes the inequality, the statement of inequality, true statement, will be called a solution. Okay, so suppose we had kept it as, suppose 30x is less than or equal to 300. Okay, so for all the less than for all the values of x, which would give us 30x as a the value of 30x to be less than 300, we have already found out. Okay, 3, 4, 5, 6, 7, 8, 9. Okay, but since now we have put an added condition over here that 30x is less than or equal to 300. So then when this condition comes, okay, where we are saying that it can also be equal to 300, we can put even the number 10 as the form of the or as the part of the solution set. Okay, so x is equals to 11 will still make the statement false. So we are still not uh, considering x is equals to 11. Okay, statement will be false. But if you add this added, kind of condition that 30x can also be equal to 300, so you will get another value of x that would be included in the solution set. Okay, so another example, if we take, say, 20x is less than or equal to 170. Okay, let's take this. So for x is equals to 0, you have 0 less than 170. X is equals to 1, so you have 20 less than 170. It's equals to 2, 40 into 40 less than 170. X is equals to 3, 60 less than 170. 50 less than 170, x is equals to 500 less than 170, is equals to 6, 120 less than 170, x is equals to 7, x is equals to 8, so we have 160, so we are also putting the less than or equal to sign. Now over here, even though we have, put the sign that 20x should be, the value of 20x x should be less than or equal to 170. Okay, so you can see that for 0, 1, 2, 3, 4, 5, 6, 7, and 8, the statement is true. Okay, but for 9, we as it is greater than 170. Okay, for when x is equals to 9, and it is also not equal to 170. Okay, so this will remain false. So therefore, your solution set for the inequality 20x is less than or equal to 170 would be 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so no matter over here that we have included the equal to sign. If we for suppose we so for 20x, if we change it, okay, for 20x is less than 170, the solution set remains the same. Okay, 3, 4, 5, 6, 7, 8. Okay, it will still remain the same. There is no change over here. Okay, so this is how you can identify all the values of the one variable that is being used. Okay, over here it was easy, to understand whether the inequality or what values of x will be used to make the statement true. Now we will see how we can solve linear inequalities. Okay, So for equations, suppose you have 3 if for an equation. Okay, so 3x is equals to say 6. Okay, so you can, kind of do some of the, there are a few rules which you can use. Obviously, if you can, you can directly divide the two sides and then you can get is equals to 2. But the other ways that you can do this is if you, minus, uh, say, 2x and 6 minus 2x, suppose you take, so this is x is equals to 6 minus 2x, and if you take this over here, so so we are not really considering this part. Obviously this will again give you the same thing, but this is a step that you can do. Okay, for equations you can add and subtract equal numbers on both and 2 and subtract from equal numbers on both sides. Okay, and similarly, if say this is 3x is equals to 6. Okay, so if you divide this by 3 and divide this by 3, you will get x is equals to 2. Okay, so the equal numbers can be divided or multiplied also. Okay, so for equations, okay, so this is only for equations. Okay, you can multiply or divide. Okay, so this will also be actually or divide by same non-zero number. Okay, so over here, as we saw, we could divide 3x by 3 and 6 by 3, and we could quickly solve the equation and get x is equals to 2. Okay, so these are the rules, or these are some of the steps that we can do for equations. Now, for when we come to linear inequalities, okay, so the first rule, so let's mark this as rules for solving linear inequalities. Okay, so the first rule that we have, kind of already seen even in the, form of the equation. Okay, that equal numbers can be or may be added to or subtracted from both sides of the equation. Okay, so the first one remains the same. Equal numbers may be added to or subtracted from both sides of the linear inequality. Okay, so suppose you have 3x plus 2 is less than 6 or less than 8. Okay, so suppose this is what you're given, so you can subtract both sides by say minus 2. So you have 3x plus 2 minus 2 is less than 8 minus 2. Okay, so what you get is 3x is less than 6. Okay, so this is a way that you can do. And then once you can reduce the statement to a simpler form. We will see how we can solve this. There are what kind of steps that we can follow for this. Okay. Now the second rule, that for equations we saw that you can multiply or divide by same non-zero number on both sides. Okay. So similarly, you can. There is an exception to this rule. So the for second rule we can write as both sides of the linear inequality can be multiplied or divided by the same positive number. Okay. So if you have 3x plus 2 less than 8, okay, so you can if you want to divide the entire thing by say 2 by 2, so this you will get 3 by 2x plus 1 is less than 4. Okay, so you can get it in this form also. So over here you can see that the sign does not change over here. But so the third rule, okay, which is actually an exception to the second rule itself, okay, if both sides of linear inequality are multiplied or divided by negative by same negative number, the sign of inequality changes, or better to write is reversed. Okay. So, for example, we had, I had explained one example. So, if you have 3 more than 2, if you multiply both sides by -1, so if you write -3 and -2, now this actually reverses the sign of the inequality because -3 is less than -2, whereas 3 is greater than 2. Okay. So this is how you write. So suppose if you take another example, say -4 is less than -1. Okay, so if you multiply it, okay, by say uh, you multiplied by -2, so what you get is -4 and -2. Over here you leave the place of the sign, because this will automatically be reversed. Okay, why? Because now you have 8 is greater than 2, which is a fact which we know. Okay, so that is why when we are dealing with inequalities, if you have to multiply or divide the both sides of the linear inequality with a negative number, the inequality sign will have to be reversed. Okay, so this is something that we have to remember when we are solving. Now let us consider a few or steps, okay, that we can use to solve linear inequality. Okay, so some general steps that we can do. So if you have steps Steps to solve a linear inequality. Okay. So the first step that we have is, suppose you are given a statement. Okay, so whatever, if you are given a worded statement, you have to represent it in the form of the linear inequality. Okay, so first step is to obtain the linear inequality. Okay, now the next one is, you can do one thing is that you can get all the you know how we solve for an equation also. So suppose we have 3x plus 2 is equals to x plus 3. Suppose this is kind of the equation that we have. So what we do in equations, while solving equations, you get all the variables on one side. So 3x minus x is equals to 3 minus 2, variables on one side and all the constants on the other side. So it becomes easy. 2x is equals to 1. Okay. So, to simplify it. So the next step that we can do is drag all the variables on one side and constants on the other side. Okay. So we can do a similar fashion. Now the third one is that we will simplify. Okay, so you simplify. So either you are left with just one variable term, and the on the other side we have like one constant. Okay, similar to how we can uh, get for the linear equations. So simplify the final inequality. Now you can, the for the fourth one, what you can do is that divide both the sides with the coefficient of the variable. Okay, so similarly over here, when we have the equation, so if you divide 2x is equals to 1, okay, so divide both sides by 2, you are left with x is equals to 1 by 2. Okay, so this was easy for us to find. So similarly, even when you're solving linear inequalities, you can do that. Okay, so now remember that when you are dividing it, so if the coefficient is positive, sign of inequality remains same. Okay, so this remains same if you have a positive coefficient and you're dividing also on both sides with by the positive coefficient itself. If the coefficient is negative, sign of inequality is reversed. Okay, so less than will become greater than, or less than or equal to will become greater than or equal to, and vice versa. Okay, so these are some easy, kind of easy steps to follow through when we are trying to solve linear inequality. Okay, so let's take some examples. We'll solve a few like questions. So the first question, suppose you are given is x minus 3 is greater than 3x plus 5. Okay, so find solutions of Or let's just begin with, you know, simplify the linear inequality. Okay, so let's try to get it in the form of, just linear inequality in the simplest form. So now this is already in the linear inequality form. Okay, so let's do with the second step, that is drag all the variables to one side. So you can write it as x minus 3x is greater than 5 plus 3. Okay, so now this becomes minus 2x, okay, less than 8. Now you have two options. Okay, so either you divide both sides by a positive number and keep the inequality sign the same, or you can divide it by a negative number and you have to reverse simultaneously the inequality sign. So suppose you have minus 2x divided by minus 2. So now since we are dividing the left hand side by minus 2, and we will do the same with the right hand side. So the inequality sign changes and that becomes 8 by minus 2. So now this becomes x is less than minus 4. Okay, so this is the simplified linear inequality. Now suppose you have to find the kind of, the solutions for x. So x has to be less than minus 4. Okay, so if it has to be less than minus 4, so there are no positive numbers that can be considered over here, and minus 4 too will not be considered. So anything from, say minus 5 to minus 6, minus 7, all the way up to your last ever, say integer that we have. So uh, we can get the solution set in the form of this. Okay, so this is your solution set for the inequality. Okay, so let's take another question. Suppose you have x minus 2 is greater than 2x plus 5. So you can, simplify this, or you can drag all the variables to one side. Okay, so suppose we, to get, to simplify this. Okay, so simplify and find the solution. Okay, so you can write this as x minus 2, and you can, say if you want to remove the variable from the left hand side. Okay, so this will remain the same. The linear, the inequality sign remains the same. You have 2x plus 5 and minus x. So what you are left with is minus 2 is greater than x plus 5. So now if you take 5 on the other side, so you have minus 7 is greater than x. Okay, so therefore x is less than minus 7. Okay, so this is your simplified linear inequality, and your solution set again over here will start from minus 8. Okay, because we are saying that x has to be less than minus 7. So minus 9, minus 10, and then all the way up to your infinity. So this is your solution for the inequality. Okay, now, so suppose you have a question. Okay, so if you remember the questions that we were solving maybe, in the last class, or let's take the other one. So suppose you have 30x less than 170. Okay, so this is we saw, this question, we saw the example where we were trying to see for which values of x will we, have the statement as true, and then we, started solving for each and every value of x. So there is an easier way to do this also. Okay, so suppose you are given two conditions, okay, that find x or find the solution set if a x is a natural number. Okay, so we want to find the all the values of x which are natural in nature. Okay, so how do we solve this? So you have 30x less than 170. This is already in a simplified inequality form. So let's just divide both the sides by, say, the coefficient of the variable. That would be easier for us. So this becomes 30 cancels. Okay, so x is should be less than 17 by 3. So that actually comes out to be less than 5.66. Okay, so now we are saying that x has to be a natural number. So, okay, so it has to be less than 5.66. So therefore, the solution set that we have will, start with 1, because we are considering natural numbers. So you have 1, 2, 3, 4, and 5. Okay, so we will stop at 5 because it has to be less than 5.66. Okay, so this is your when we want to find the solution for when your x is a natural number. I'll write it down below. Okay, so therefore x is equals to 1, 2, 3, 4, and 5. Okay, let the next condition, if suppose that x is an is a actually wait, x is an integer. Okay, so when we are trying to consider an integer, so over here, all the kind of, all negative numbers are also included. Numbers included. Okay, so again, if we solve it in the same manner, your x will still be less than 5.66. Okay, but now your x, okay, so the solutions that we have for x will be, okay, so this will be, let's start from the highest that we have. So it will be less than 5. Okay, and then you have 4, 3, 2, 1. Now 0 will also come here. Okay, and then you have the negative number. So -1, -2, -3. Okay, so all the way up to the last, the integer that you can have. Okay, so all the negative numbers will actually come within this solution, because we have considered x as an integer and we are trying to find the solution. Okay, and if you have x, okay, see if x is a real number. Okay, so suppose your x becomes a real number. So the solutions will now have, it will actually consist of all the numbers, on the negative side, all the way up to your infinity, and the positive numbers only up to the number 5. Okay, because this condition does not change over here. So then if your x is a real number, you can have x is equals to, okay, so you have all the way up to minus infinity, all the numbers, and you can write -3, -2, -1, 0, and then you have 1, 2, 3, 4, and 5. Okay, so you can see that this is the way we can provide the solutions for a linear inequality. And you can see that there is a large range of values for a variable that can be used, or that can be called the solutions for the linear inequalities. So when you have linear equations, you either you get usually one, you will either get the one solution for, say, linear equations. You get one solution. Okay, so say a positive solution or a negative solution also. Okay, so you can have like a positive and negative value for x when we are trying to solve a, it can be, it can be either positive, okay, either it will be a positive or a negative. Okay, but when we are trying to solve for linear inequalities, we can see that it can have a varied range from a positive to the negative numbers if there's only one singular limit that has been placed. Now, if you remember that you can have kind of the literal inequalities where only one sort of inequality is given, but you can also have double inequality where you have double limits that are set. Oh, in that case, you will have a certain range, okay, only a certain range of x values. So maybe later on we'll see some kind of examples on those also. So for today, we will stop here, and in the next class we will do a few more examples where we will try to convert, worded statements into linear inequalities, and we will try to solve for them. So we will solve for them, and either we will have some conditions like x has to be a natural number or an integer or a Jodi number. So this is something that we will deal with in the next class. So thank you. Hopefully this helps.